Okay, and welcome back to solving problems for chapter 3 from the study guide. Let's go to analyze the first problem. The first problem says like this. It says these figures show velocity and acceleration vectors in several situations. In which case is the object's velocity changing while its speed is not changing? Wow. This is a problem that is not well defined, the description of the problem is not very good. We are going to see the ideas. The ideas is like this. What it means acceleration? It means that there exists a change in velocity divided by the change in time. But now the change in velocity is a vector. This is a vector. And this vector divided by delta t by the change in time is a vector that is reduced or stretched in the same direction delta v. So the idea is like this. The object is moving with velocity v sub I. Now it comes the change in the velocity. The change in the velocity produces that v final will be v initial plus the change in the velocity. V initial plus the change in the velocity is v final. Perfect. So v final change in direction. The initial direction was this direction. The initial direction was this direction. And the final direction is this direction. So it changed in magnitude. The length of the vector is bigger in this case, and it's changed in direction. The initial direction, it was like this. The final direction, it was like this. So this equation is essential to understand Newton's law and to understand the solution to this problem. So the change in the velocity, the change in the vector velocity, the vector change is a by delta t. So the change in v is a by delta t. So this is the change in the vector velocity. Now that we understand this thing, we have to understand that we have to sum v sub I to the change. We cannot sum v with a. We have to sum v with a by delta t. This is the change in the velocity because v has a unit of meter per second and a have the units of meter per second squared, so I cannot sum it even if they give me the vector. I can sum it with something that have the same units. And delta v, the change in velocity, have the unit meter per second because a have unit meter per second squared multiplied by seconds, it will have unit of meter per second. Once that these ideas are well understood, we are going to analyze the problem. So in the first case, in the case A here, let me see, okay, the case A, v sub I is going in this direction. Okay, v sub I is in this direction. A by delta t is going in this direction. So if A by delta t is going in this direction, the final velocity will go in this direction. So it will grow up his speed, the length of the vector will be bigger, and it will change the direction. But the problem says that you have to find a case where the change in the velocity, the magnitude of the velocity will not change. So that means that if you draw a circle of radius v sub I, the velocity should be here in this case. Okay, let's go. So the case 1 will not work. Let's go to leave the case B for the last part of the problem. So in this case, in the case C, the V is in this direction, the A is in this direction. The acceleration will produce a change in the velocity. A by delta t will go in this direction because you are amplify the vector by the factor delta t. So A by delta t is in this direction. Vi, the initial velocity, is this one or this one. So V final is the vector V final, this one. This is V final, this is V initial, and this is A by delta t. Does it change the magnitude? Yes. Does it change the direction? No, but the magnitude has been changed. So the direction of the velocity in this case is not changed, it's only produce a change in the magnitude of the velocity. So this A parallel to B will produce a change in the magnitude of the velocity. Now this A that is not in the direction of B, like in this case, will produce a change in the magnitude of the velocity and in the direction of the velocity. So V is in this direction. A is going up. How I will sum? V A by delta t will go in this direction. Whatever is delta t, 3 seconds. Wow, more 10 seconds. A by delta t will be bigger. So B initial is this vector. V final is V initial plus the vector A delta t. Okay, let's say that A delta t is this vector, A delta t, bigger vector. So the V initial is this one, and the V final will be this one. So in this case, the velocity final will change the direction and will change the magnitude at certain times. Now it looks like an equilateral, like an isosceles triangle. It looks that this length is very similar like this length, but it has some times where the length is not similar. So in general, we can say that in this case, the acceleration produces a change in the direction of the velocity. Now it's here, or now it's here, in this direction, and it produces a change in the magnitude of the velocity. Now let's go to the case V, that is, I suppose, is the answer. Now, V is Vi, is the initial velocity. Now, A by delta t is being applied, but it's being applied by a very, very short time. So A by delta t is this vector, this small vector. So the V final will be this one, V final. So what happened? Incredibly speaking, and using the calculus, the magnitude of V final will not change. You will say, wait, but if I apply Pythagoras theorem and I have this amount, A by delta t, and this amount, V sub I, the hypotenuse is always bigger than this plus this. How you could say that this magnitude of the velocity will not change? Oh, I'm assuming that delta t is very small. I'm assuming another fact. The other fact is that A by delta t, the vector A by delta t, will act always perpendicular to the velocity. So now, A by delta t will act perpendicular to V final. So the new velocity will be like this. Now A by delta t will act perpendicular to V final. So the new velocity will be like this. If you do it like this, the new velocity, if you do it like this, the magnitude of V final will not change. If A by delta t is perpendicular to the V, to this V, to the final velocity, will produce a new V that will not change its magnitude. The radius of this circle of magnitude vi will be constant. And this is what is happening in a motion with circular motion. The problem is not well written because it doesn't say that delta t is smaller, so delta t very, very small. And also it doesn't say that the vector A by delta t is always applied perpendicular to the final velocity, is always applied. So if you understand this motion, you will understand also circular motion, and you will understand how the acceleration is working. To the next problem. The next problem is a problem of projectile. It says a projectile is fired from the origin, y equals 0, so the origin is here. Here is the origin, so this is the origin, this is the 0, 0. The 0, 0 is here. Okay, so it's the initial components are V0x 940 and V0y 96. So it means that it has a lot of initial velocity in the x direction. So the vector velocity is something like this. Very, very 940 meters per second in the x direction, and only a small velocity, 96 meters per second in the y direction. So the angle that the velocity is making, the initial vector velocity, is composed of the velocity in the x direction, 940, and the velocity in the y direction, 96. So in this problem, the initial velocity, this angle, is very small. Okay, it's not horizontal launch. You don't fire at horizontal, but it says 30 degrees here. Oh, I didn't pay attention. How can be 30 degrees? Wow, this problem is wrong. Cannot be 30 degrees. Wow. What is 30 degrees here? Let me erase here. Let me erase this. You say 30 degrees here? No, cannot be 30 degrees. This problem is wrong. This 30 degree is not true because if you see the vector velocity, this angle here is not 30 degrees. Sine or tangent of alpha is 96 divided by 940. Later on, alpha is arctangent of this amount of 96, and it will be maybe 10 degrees. It will not be more than this. So 940, so I don't know, something is wrong in this problem. Okay, let's go to imagine that the 30 degree doesn't exist. Let's say the projectile reached maximum height at point P. Then it fall and strike the ground at point Q. Okay, so this is the maximum height. This is the maximum height, and is when the velocity Vy is 0. So the velocity V is horizontal, have only Vx components. Okay, at the point P. The y coordinate of the point P is closest to the y component. So it's asking about what is this y? What is this y? Okay. So the equation that you are going to use are the equation for the x direction is a motion with constant velocity. The 940 meters per second here, this velocity, will never change his amount because there is no acceleration in the x direction. The velocity, the 940, will be here, will be the same that here. What it will change is the Vy velocity. because in the y direction there is acceleration, and the acceleration is minus 10 meters per second squared going in the negative direction as the y. So for the x direction, I will use the equation of motion for constant velocity. For the y direction, I will use the motion of constant acceleration in the y direction. So this is ay. Okay, so the by start at 96 meters per second. So as time will pass, the velocity will decrease, and decrease, will be zero, will be negative, more negative. And the equation that the Vy will follow is the equation Vy equal V0 y plus a by t. That is the equation of motion with constant acceleration. So in our case, Vy will be V0 y 96 minus a is negative minus 10t. So in this case, so what we will do here is the projectile, the problem say the projectile reaches maximum, the y component of the point P, the y component of the point P, this height. How I will find this height? This height occur when Vy 0, when there is no y velocity, Vy 0. So I will plug in Vy equals 0, and I find the time t at which the velocity Vy 0. This happened to be at 9.6 meters. So the velocity Vy start at 96, go down, and when the time t is 9.6 seconds, the velocity is 0. Later on, the velocity is negative. Okay, so because it's a motion with constant acceleration, in the y direction, I will use the equation for constant acceleration of position, of displacement. So y of t is y0 plus v0y plus 1/2 at squared. I will plug in the numbers from here. Y of t will be y0. Y0 is 20. Oh, it's 20 meters. Plus v0y is 90.6t because v0y is going up with 96 meters per second. Okay, minus 1/2 divided by 10 is 5, minus 5t squared. So y of 9.6, let's go to correct this. Y of 9.6 is the height of the object when he is at the time t equal 9.6 seconds. So it will be 20 plus 96 by 9.6 seconds minus 5 by 9.6 squared. If you make the calculation, you will find y, but the y that you will find is this y. Let's go to see which one is this y. This y will be 96 by 9.6. Okay, y, the maximum height at 9.6 seconds, will be 20 plus, now if you make the calculation that I didn't do it, it will be y0 is 20, 96 by the time t is 9.6 the time t minus 5 by t squared, 9.6 squared. If you find the y at this time at 9.6 seconds, the y will be 480, but I have used the g like 10. So maybe it will be this answer, the correct answer. Let's do the next one. So the next one is a problem that is very similar, is quite similar. It's a projectile at t equal 0 seconds is being launched from this point. So this point is the point y0. Oh, in the last problem they say that this was the center. So let me see the last problem. Nothing. It's correct, it's correct. Okay, with initial component V0x 50, V0y is 200. So the velocity do like this. It's 50 meters per second in the x direction, and it's 200 4 times. 4 times is 200 meters per second in the y direction. So the vector velocity is the vector, this one is with a big angle. It's launched with a very big angle. The angle is very big. Okay, so it say the projectile rise then fall into the sea at the point P. The time of flight of the projectile is 50 seconds. So it means that it takes 50 seconds to go from here to here, to the point P. So with this information we can find the y0. This information is related with the y0. We will see. And the questions say, when x equal 1,000 meters, when is the y? X equal 1,000 meters, let's say that is here, x equal 1,000 meters. So what is the y? What is this h? I don't know what is the x equal 1,000 meters, because I need to find the d. Now let's say if I found the d correctly, the d should be, if he delay 50 seconds to strike the floor, he will move in the x direction with constant velocity. The distance d, capital D, is the velocity in the x direction that is moving by the time t. The time t is 50. The velocity in the x direction is 50. So he's moving in the x direction, this x direction, all the time during 50 seconds. So he will move in the x direction. It will move 2,500 meters. So the d is 2,500 meters. So if d is 2,500 meters, the x is here, is 1,000 meters. The x 1,000 meters is not where I draw here, is here. But I don't know if this graph is correct, graphically speaking. If maybe it's more like this, I think, more like this, okay? Okay, doesn't matter. So what happened with the y? The y is a motion with constant acceleration, and the equation that track the position of the particle as the time goes is the equation with constant acceleration, this equation. This equation in our case will be y0, v0y is 200, a is minus 10 minus 5t squared. So I have two equations. The equation 1 for the y is this equation. For the equation x, for the x is v by t. V0 is 50, and when he strikes the floor, the t is 50 seconds. So what it says, this equation, is that when t is equal 50 seconds, it strikes the floor. The floor is when y equals 0, the height is 0. So I will plug in equation 1 this information, that t is equal 50 when y equals 0, and I will have 0 equal y0 plus 200 by 50 minus 5 by 50 squared. And this allows me to find the y0. The y0 is, in this case, is 2,500. If I didn't make any mistake, if I made a mistake, you will tell me. So the object is launched from 2,500 of height, and he will arrive 2,500 meters in the x direction. And he's launched from y0 2,500 here, 2,500. So the equation of y of t is y0, 2,500, plus v0y 200 by t minus 5t squared, this equation. And the x is 50 by t. If x is 1000, which means that when x is 1000, I will plug in 1000 here, the t will be 50 by t, so the t will be 20 seconds. So if I have the t at x equal 1000, that is 20 seconds, what will be the y? So I will plug in 20 here and 20 here, and I will see what is the y. If you do it, you will find the y. So the y of 20 will be 2500 plus 200 by 20. This is y at the time t equal 20 minus 5 by 20 squared. So it would be 2500 plus 200 by 20 is 4000. So this is 4500. This is 6500. So the total is 4500 meters. So when y, so he's launched in this way. He's launched in this way. He's launched from 2,500 meters. He arrived to 2,500 meters. So the graph is doing like this. And when you are at 1,000 meters, the height should be bigger than 2,500. You see that you are very next to the... this height, it says that is 4,500 meters. Okay, when x equal 1,000 meters, the y is 4,500 meters. So if they want me to tell you, if the problem wants to me to answer this height, only this height, it will be 4,500 minus 2,500. So this height will be, total is 4,500 minus 2,500 equal 2,000 meters. Probably he wants me to tell you these 2,000 meters. So if we go to the equation, there is something that says something like 2,000 meters. So it could be this one. Could be this one. Yes, could be this one, 2,040 meters. Let's go to the next problem. The next problem is a problem about motion in a circular motion. In a circular motion, there is acceleration. There is acceleration because even if it's a uniform circular motion, the word uniform means that the velocity, the magnitude of the speed is not changing, but of course the velocity is changing all the time in direction. But in a circular motion, uniform circular motion, the length of the velocity, the magnitude of the velocity is not changing. But of course the direction is always changing. So there is acceleration going inwards to the center. And the acceleration is v squared divided by the radius. So the problem says you have two objects, two particles. Particle A is moving with certain acceleration. The acceleration is 4.7 times the one that of the particle A. If the acceleration of the particle A is bigger, that is 4.7 times the acceleration of B, is because the radius RA is smaller. Because he has to change his velocity more drastically here than here. Here is almost more rectilinear, so it has a smaller change in the velocity. But through here, the change in the velocity are more radicals, more violent, so you have more acceleration in this one. So it says the acceleration of the body A is 4.7 times the acceleration of the body B. And the time that the body V compared to the time of the body A, you know the body V, it will travel with a circle of radius RV, and it will travel during a bigger distance. So the time that the object V will perform one revolution, this time t refer to the time of the period, the time that takes place in one revolution, is bigger than the time of A. Is 2.4 times bigger than the time of A. And what it says is find a relation between the radius. What are the relations of the radius? So this is not a physics problem, it's more a mathematical problem. So let's go to do it. The acceleration of A is VA squared divided by the radius A. VA, what is VA? VA is because he moved with constant velocity, is the distance that he traveled divided by the time that he delayed in one revolution. The distance that he traveled in one revolution is 2 pi RA. And the time that takes to make one revolution is T sub A. The period is the time that takes one revolution. So AA is VA squared divided by RA. VA squared is the distance traveled divided by the time that takes to travel. It travels during the distance 2 pi r, because 2 pi r is the length of the circle. So 2 pi r, the distance travel, the length of the circle to perform one revolution, divided by the time of one revolution, this is VA, because it's a constant velocity, it's uniform motion, it's uniform circular motion, divided by the radius. If I make some algebra here, it will be 4 pi squared, RA, 1 RA will be cancelled, TA squared. For AV will happen the same thing. Now I have to find the relation AV divided by AA, so I will divide AV divided by AA, or AV this divided by this. If I divide, I will find another mathematical relation that will say that AV divided by A is TA squared divided by TV squared RV divided by RA. But what is asking me is what is RV divided by RA or RA divided by RV. AV is AV. AA is 4 times 7 AV. This will make that AV will cancel. AV will cancel with AV. AV divided by AA is TA squared divided by TV squared. But TV squared, TV is 2.4 times TA. TV is longer, 2.4 times TA. But it says square, TV square. So this is TV, 2.4 times TA square. Now, again, it will happen the same thing. The TA, the TA square and the TA square will cancel. I will have, if I plug in numbers, I will have 1 divided by 4.7. TA is cancelled with this TA. So 1 divided by 2.4 square. RV divided by RA, so I have it. RV divided by RA is 2.4 squared divided by 4.7. But I think that the problem is asking you by RA divided by RV, so it will be the opposite, the inverse, 4.7 divided by 2.4 squared. Check it if it's correct. Should be one of the result. Okay, let's say this problem. Let's say like this: an aircraft. This is the aircraft. Make a maneuver called an aileron roll. I interpret that an aileron roll is when the aircraft is rotating through his axis and not changing the direction. So he's rotating, pure rotation. He's rotating through his axis and is not changing his direction. So the wings, I have to suppose that the wings are not like this one that have an angle. The wing, I would suppose that are in a 90 degree. So the wings will accelerate, will have normal acceleration. He is rotating at constant angular velocity. So the wings, every part of the wings will have a rotation around the axis. This is the plane. This is the plane. Okay, this is the wings. This is the wing. So this is the wing. Okay, these are the wings. So the wings, every part of the wing will rotate. So the wing have a structure that you cannot make too many forces on them because the wing can break. So the maximum acceleration is say that is 4 meters per second square. If the wing span at 8.9 meters, so what is if the wing if the radius of the wing is 8.9 meters, so this is the wing, and this is 8.9 meters. Okay, so every point will make a circular motion around this axis. What it says, if you can only create acceleration of 4 meters per second square, and if the radius of the wing is 8.9 meters, what is the shortest times it can make a full turn when it performs an aileron roll? When he does this motion, rotating through this axis. I suppose that this is an aileron roll, but I'm not sure. Okay, so this is also a mathematical question, more or less. The maximum acceleration is 4 meters per second square, and the radius is 8.9. So the acceleration in a circular motion, the acceleration that will go in this direction, to the center. So this small wing, this is the wing, will suffer an acceleration in this direction. So the acceleration in this direction will be v squared divided by r. It depends on where you are, and the acceleration is v is omega by r. We are going to do it in two ways, and we check it if they work. V is omega by r square, v squared divided by r. Is omega squared by r, because 1r squared will cancel with this r. Omega is the change in the angle divided by the time that delay square by r. But if I choose the change in the angle to be 2 pi, the period, the time that takes to make one revolution will be t. So this is squared by r. So it say, what is t? Okay, I can find t from here. T will be 4 pi squared by r divided by a. You see the t will go in this direction. So t squared will be 4 pi r squared multiplied by r divided by a. The other way to do it is to use this equation, to use the same equation in another way. The acceleration is v squared divided by r. V squared is the distance traveled, 2 pi r, divided by the time that takes to displace 2 pi r, to move the length 2 pi r through the circle. The length of the circle is 2 pi r, divided by the time that delay is the velocity. So, if I make some algebra here, it will be 4 pi squared. 1 r squared will cancel with this r, t squared. I will take this t squared, will be 4 pi r squared r divided by a. So if I plug in numbers, r would be 8.9, a will be 4, the 4 will cancel with this 4. So the t squared will be pi by the square root of 8.9. So this is the time, and the problem is done.